Right, so we're going to have a look at testing for anions. The three anions we're initially going to look at, testing for chloride, bromide, and iodide. So let's say we've got a solution and we think it contains either chloride, bromide, or iodide. What are we going to do? Well, we add some nitric acid to it, and that's just to make sure everything is dissolved. And then we add some AgNO3. AgNO3 is silver nitrate solution. So we add the silver nitrate solution to our solution, which we think contains chloride, bromide, or iodide, and we're going to get one of three results. We're either going to get a white precipitate, or we're going to get a green precipitate, or we're going to get a yellow precipitate. If we get a white precipitate, that means chloride was in my original substance. If we get a cream precipitate, then it means bromide was originally in there. And if we get a yellow precipitate, it means that iodide was initially in there. Of course, if we don't get a white, cream, or yellow precipitate, it means that neither chloride, bromide, or iodide were in there. That's the basics. We'll go into a little bit more detail now to find out exactly the origins of this, but this is really only for the higher grades, for these 7s, 8s, and 9s. So, although this looks a little bit complicated, let's break this down. Let's suggest that our original solution contained sodium chloride solution, aqueous. We've added silver nitrate aqueous solution to it. Because these are solutions, these salts, the sodium chloride is dissociated, which means it's been split up into ions. The silver nitrate is dissolved, so it's also dissociated, which means it's split up into ions. That means swimming around in this mixture here of these two, we've got sodium and chloride ions and silver and nitrate ions all swimming around. Because all sodium salts are soluble, not going to do anything, it's not going to react with anything, and same with the nitrate. The chloride and the silver, however, silver bumps into chloride and it's insoluble, so it sticks together and stays stuck together as a solid. And that's why we see a precipitate. And silver chloride happens to be, you guessed it, it's white coloured. So what we've got is these ions here, the sodium and the nitrate ions, are our spectator ions. They're just watching. They're not involved in any reaction. The green boxes show the ions which join together to make this stuff here, which is our solid. Everything else is aqueous. Our solid, which is our silver chloride. Let's have a look at the bromide example. Exactly the same. We've got sodium bromide and silver nitrate. This is soluble, so it's split up into ions. This is soluble, so it's split up into ions. When this silver bumps into the bromide, it's insoluble, so it sticks together and forms the solid, which is a precipitate. And of course, the colour of this precipitate happens to be cream coloured. Lastly, we've got sodium iodide floating around and silver nitrate floating around. The silver, when it bumps into the iodide, it produces silver iodide, and that's solid. It's insoluble, so again we form a precipitate, and the colour of this precipitate is yellow. So that's testing for chloride, bromide, and iodide. Remember, if you get a white precipitate, it's chloride, green precipitate, it's bromide, and yellow precipitate, it's iodide. If you don't get a precipitate at all, it's none of those, in which case you might go on to test in a different way if you want to find out what the anion could be. So let's say you think it might be sulphate in here. What are we going to do? Well, we add some acidified barium chloride, again acidified to make sure it's dissolved. If we add the barium chloride to my unknown solution, if we get a white precipitate, then that means the original solution contained sulphate ions. So let's have a look again at the reactions. So let's suggest that my original solution contained potassium sulphate. Potassium salts are soluble, so it's ions and ions. They've dissociated, they're dissolved. Barium chloride also dissolved, so it's dissociated. So you've got these four ions swimming around. If the barium comes into contact with the sulphate, it's insoluble. Barium sulphate is insoluble. So when these two join together, they form my barium sulphate, which is a solid, and it happens to be a white solid. So my spectator ions are the ones that aren't involved in the reaction, and the green ions are the ions which come together to form my precipitate, which happens to be white in this case. So if we add acidified barium chloride and we get a white precipitate, we know that the original solution contained sulphate. If it didn't give a white precipitate, we've got to try something else. Let's say, well, let's add an acid. If we have a solution which contains carbonate ions, and we add any acid to it, for example, hydrochloric acid, if it fizzes and the gas that's produced turns lime water milky, that means carbon dioxide has been produced, which means our original solution contained carbonate ions. So here's the reaction. We've got potassium carbonate solution, aqueous. We're adding hydrochloric acid. That 2 shouldn't be there. And we produce potassium chloride and water. And this is the important point, carbon dioxide, which is the bubbles. You can then test the carbon dioxide with calcium hydroxide, which is lime water. And if you get that white precipitate, that creamy color, that cloudiness, then you know it was carbon dioxide. That carbon dioxide in turn tells you that you started off with a carbonate.